Hey, hello everyone. My name is Saina, and today we are starting a new Kubernetes project series. And this is our first Kubernetes project series. And we in this series will do a set of Kubernetes projects, each project covering the concepts about the Kubernetes from basics like pod deployment, port forwarding, to the advanced concepts like ingress, monitoring, secret management, and other advanced concepts about Kubernetes. Each project will cover the some of the concepts of Kubernetes, and on those concepts we will build a project, and each project will gradually increase the level because most of us, including me, faces this problem that we know the theoretical concepts about Kubernetes, but when it comes to applying that concepts in a actual project, we get stuck. So to overcome that, I have started this series where each project will cover some of the concepts about Kubernetes and apply that concepts in the real world project. So this is the first project where we are deploying a React application on Kubernetes, which is a Minikube cluster, and this is the README for that project I have created. You guys can take a look. I have given a complete guide for installation steps and the concepts. If you want to brush up the basic concepts like pods, deployments, which that we'll be using in this projects, you can see that here also. And in this project, we are using a Minikube cluster that will run on a EC2 cluster, EC2 instance, and on that cluster will execute our workload. And if you guys are new to my channel, make sure to like and subscribe because that really motivates me to make more such content. And I have already made some more interesting videos like Jenkins pipeline, AWS cloud cost optimization tool, a complete EKS cluster project. You guys can take a look at over there also. So without getting late, let's get started. Now come to our AWS EC2 console, and in this we'll launch an T2 medium EC2 instance. On that instance, we'll launch a Minikube cluster. And if you guys have Minikube in the cluster installed in your local, you can execute your workload over there also. That is totally fine. So now we'll launch a cluster, sorry, a Minikube instance. Once your instance is running, connect to that instance. Once you are connected, update your instance. Now once you are done updating, move to your in this readme file. I've given the complete installation steps. After update, we need to install a Docker. So let's install that first. So next we'll install the kubectl. So this is the command for that. So kubectl is also installed. So next is we'll install our Minikube. So our Minikube is also installed now. So now run this command to run your Minikube cluster on this EC2 instance. So this will run a Minikube cluster on your instance. Now to verify, you can check kubectl get nodes. So this is our cluster with watching just a single node. So our cluster is up and running. Now let's start our workload. So let's first create a namespace. So vim. So in this namespace, let's write our configuration. So first we have is kind. Kind is our namespace. Now how to get the information about this kind and API version? For that you can use this command, that is kubectl API resource -o wide. So you'll get the complete information about the resource you are using, which short name, API version for that, and the kind for that, everything. But for specific, you can just simply grab that. That is this grep namespace. See, you can get the information about that. So this is our API version, and this is the namespace that we are using. So kind. This is the kind, and this is the namespace API version. Same thing you can get for all other also. So next is our API version, that is V1, and next we'll write our metadata, and in this metadata we'll give the name for this namespace as and then simply we'll apply that. So namespace is created now. We can verify that. See, our project one namespace has been created. So now our namespace is created. Let's create the deployment now. So again, for this deployment, where to get from kind and API version information? You know, again, I have told it that in my previous command, that is using kubectl API resource -o wide. So you can get information from here. So this is our kind, and API version is app/v1 metadata. Let's give the metadata as app deployment. This metadata name will define the name of this deployment. So the name of this deployment is app deployment, and in which namespace do you want this deployment? That is that we have created just now. That is our project one. So that is our namespace, and next is to write the specification. In the specification, firstly we will write the replicas. So replicas tell how many number of pods do you want in this deployment. That is, let's give it as a true. Two, and with replicas we also need to pass the selectors as labels. Selector labels as app my app. So this is our selector. Now let's write the template for our pod. So in this template, let's first write the metadata. Metadata, let's give the label. These labels, and next is app as my app. Make sure this label and this label should match, because our replicas is trying to find the pods with this label. And next in metadata, we need to write the spec. Inside spec, contain information. Name of the container, and then image that this container is using. This image I have already published in my the Docker repository. You can get this from there. And next is port. This container port defines which port do this Docker file is exposing. this Docker image is exposing. So this Docker image is running at port 80. So that is what I have exposed it here. And next is simply apply that. So we got error. What it error is saying, that is spec template. Think we have created some error. Let's see. So spec template, spec template is a typo. Vim. So this was a typo. So let's apply it once again. So deployment is created. kubectl get pods. See, you cannot see any pods because we have deployed those pods in our namespace. So -n one. See, you can see our deployment, and that to two deployment. Because why? Because we have given the replica as count two. So kubectl get pods in the namespace project one. See, we have our two pods running. Let's get all. See, we have two pods running, a deployment and a replica set. In the deployment internally creates a replica set. Why? Because we have given in our deployment file that replica is two, because replica and replica deployment internally creates the replicas. Now let's create the service. So service kind is service, and API version is v1. So before explaining, let me first before writing the service, let me explain you our service. So in this service, firstly we will give the API version, next we'll give the kind, and then we give the metadata. The metadata is the name for this service, and then we give the namespace, which is our project one namespace, and next in the spec we give the type of the service. So we have different types of services, like here I have mentioned those. We have cluster IP service, node port service, and load balancer service. So cluster IP service is only used for accessible inside the cluster. Let's say you have two pods, and those two pods you want to communicate with each other, like backend pod and database pod. In that case, you will use this cluster IP. And node port you will use when you want to expose that pod to outside for just for testing purposes. So at that case, you will use this port, node port, by which you will bind the local port to your local host port. Let's say port 8080 of your local to your container port, that you will bind with each other. And other is this load balancer, which is mostly used in actual projects, industrial projects. This is provided by the cloud like AWS, and through that load balancer we will route the traffic, and this load balancer we'll use in our next projects. So coming to a service, here selector app label, because selector, why? Because it will look for the pod which who has the label as my test app, and in our deployment we have given this as a label. And in ports, this is the port of our service, this is the port of where our container is running, and this is the node port, because we have given as a type as node port. And node port, as we have given 3030, then the local port of our 30,000 will be mapped to our container port, that is 30,000. So let's copy this and let's paste it over here. I'm going to change this label here, and rest is as good as, just simply save it and then apply this. So our service is also created now. Now let's take a look at what all services we have created. kubectl get all in the namespace project 1. So we have two pods running, a deployment which created these two pods. Internally, deployment creates this replica set. And where is our service created? I think our services got created in our default, so that is a mistake. So let's first delete that. Ctl, because we don't have a namespace over here. So let's define that. So then apply it again. Again it is created. Now let's test that. See, we have two pods running, a service, a deployment, and this deployment internally created this replica set. So now as our node port is exposed on port 3030, let's try to access that. If you just you need to port forward that. How you need to do that? kubectl port forward, take this name, because we need to port forward this service. And in which namespace is this? Just one. So we need to port forward it to our local port, which is 30,000, and our container is running on port 80. And for detached mode, just hit enter. So I'm getting this error because my port 3030 is already is in use. So let's delete that first. Let's put forward it once again. So it is put forwarding. Now let's check that. Call localhost. See, I'm getting some response over here as an HTML page. So understand this. I am using my EC2 instance. So my local becomes my EC2 instance. If you are using Minikube cluster on your local instance, that is your PC itself, then you should if you go directly on your browser and hit for localhost 30,000, you should able to access that application. I am not able to access that application because here because my local is now EC2 instance. So for that, what I need to do is I need to map my local host to my EC2 instance. How to do that? This is the step for this. Here it is. So what I will do is I will go to one more tab. Go. I will go to my where my pemp file is located. So from there I will SSH into it once again. SSH. This is my pemp file, and then -l, which port, that is 30,000 of my local host, bind it to 30,000 of my EC2 of this server Ubuntu, and the port, that is, take this IP, paste it, hit enter. So now you should come here on your browser and just refresh this. You should be able to access your application. See, this is a simple React app which has a version as v1. And now we will look into how to use rolling update, so that without with zero downtime, this React application will change to the other version, that is v2. Now we'll show you that how to do a rolling update without zero downtime. And all this what you have done as a port forwarding and all, you will not be doing that port forward in actual projects, because we will be using a load balancer, and in load balancer there is no such thing like port forwarding and all. Load balancer internally manages everything. So now for the rolling update, come to your deployment file, and here change the image version as v2 and apply that once again. See here, first the container is in creating mode. A new container will be first created, then these two containers old one will be deleted. See here, it is in creating state and age is 5. Let's run this once again. See, our both the containers, new containers are created. See here, this time is 16 seconds and 22 seconds, and these old containers have been removed. And now we need to port forward that once again, because our containers has been changed now. So for that again port forward our service. See, now our new version of v2 is also deployed here. But there is one thing that we manually did everything. Like we went to our deployment file, we changed the version, we again applied the manifest file. Everything was done as a manual. This is what you need to understand. But in our next projects, when we'll also implement a CI/CD, this complete process will be automated. We'll just simply change our version in our GitHub file, and from there everything will be triggered and automatically deployed, even without user knowing that there is a actual downtime or new version has been updated. Like here happened, we just refreshed and we got the new version as v2. But we did the thing as a manual. Everything was manual process. But in next project we'll automate this procedure also, that is will not be doing any port forwarding and all. Our load balancer will handle everything. And yeah, that's it for this video. And if you are done implementing this, make sure to delete this everything. That is simply go for ctl delete ns project1. This will delete an entire namespace and all the workloads in that namespace. And once it is deleted, you can stop your instance, EC2 instance. You can then simply stop your instance. And yeah, that's it for this video.